Okay, hi everyone. Here's a quick video on quadratics and parabolas for math studies. So a quadratic has the form y equals or f of x equals ax squared plus bx plus c. Okay, here's some examples. Y equals x squared minus 6x plus 5. That's 2x squared plus 3x minus 4, and here 4x minus x squared. You're going to say, hey, that's not ax squared plus bx plus c. Well, yeah, it's bx plus ax squared plus c, and c is 0. Alright, so it might not look exactly the same as that, but it's got an x squared, it's got an x, and it could have a constant term. Again, if it's just got x squared, then it's going to be a quadratic. The name of this shape is parabola. Okay, so these are all parabolas. Now each parabola has an axis of symmetry, so that dotted blue line, and the vertex. The vertex is that turning point, the minimum or the maximum. Axis of symmetry, so it's the same on both sides. It's symmetrical. Okay, let's see if we can work out some standard things about this formula ax squared plus bx plus c. Let's see what happens when you change the a. Okay, here's x squared, so a equals 1, b equals 0, c equals 0. 2x squared, so a equals 1, 2, b equals 0, c equals 0. Okay, 5x squared. So as we're increasing the value of a, it's getting narrower and narrower. 0.5. Okay, so now it's getting wider. So if we're decreasing it, it'll get wider. Okay, if we make a negative, it's going to flip it over and be down here. So positive values of a look like a smiling face. Negative values of a look like a frowning face. And the higher the number of a, the narrower it will be, the more stretched out vertically it will be. Okay, let's see what happens when we change to c. Okay, there's x squared plus 3, so everything's moved up by 3. X squared minus 5, everything's moved down by 5. But you can see here, that's 3, and that's 5. Let's start with the red one here, x squared minus 2x. If you add 3, everything's gone up by 3, but here, the value is 3. If you take away 5, everything's moved down by 5, and here the value is negative 5. So this is called the y-intercept. So the value of c is the y-intercept. Let's have a look at line of symmetry. So y equals x squared, line of symmetry is x equals 0. It's the y-axis. Now, just keep this in the back of your mind for a minute. So a equals 1, b equals 0, c equals 0. X squared minus 2x has a line of symmetry at x equals 1. Now, you notice b is negative 2 and a is 1. Just so you know, b over 2a, negative b over 2a equals 1. X equals 1. This equals 1. Interesting. Okay, here we go. X squared minus 4x, and as the line of symmetry as x equals 2. You'll notice that negative 4 divided by 2 times a, 2 times 1, and negative also equals 2. 2. It equals 2. 4 divided by 2 is 2. Okay. Here's another one. With this time c is plus 3. So a is 1, b is negative 2, c is 3, x equals 1. Notice again, negative b on 2a also equals 1. So we've just discovered a few things. Here's another example. This time b is negative 12, a is 3, c is 1. And the line of symmetry is 2. if you do negative b on 2a, you get 2 as well. So we've discovered a few things. Another example. Ah dear. Another example. Okay, so b is 16, a is negative 4, c is 8, and negative b on 2a is 2, x equals 2 is our line of symmetry. So we've discovered a few things. A tells you about the concavity of the parabola, or the width of the parabola. Is it, how wide is it? So the bigger the a, the narrower the curve. If it's got a positive a, it's going to be U-shaped, or it's called concave up, or smiling. If it's negative, it's going to be concave down, N-shaped, or frowning. Okay, C is the y-intercept. This value of C is always going to be the y-intercept there. The line of symmetry in the vertex is going to be given by negative b on 2a. Okay, so we know a lot about a parabola now, but actually there's one more question I want to ask. What can we tell about these 2 points, the x-intercepts, also called the roots or the zeros? Okay, I'm going to call them P and Q. Well, where does the parabola cross the x-axis? Well, it crosses when y equals 0. So if we put 0 equals y, and we solve that, and then we solve that by factorizing, and then we use the null factor law. Okay, so if you got 2 things multiplied together and they equal 0, then one of them must be 0. So x equals 0 or 2, and 0 and 2 are our intercepts. By the way, x equals 1 is our line of symmetry, which is halfway between 0 and 2. Here's another example. You got this. If we put y equals 0, we can solve for where it crosses the x-axis. We factorize it. Null factor law, 2 things multiplied together, one of them must be 0. X minus 1 equals 0, x minus 5 equals 0, so x equals 1 and 5. You see that 1 and 5 is where we cross the x-axis. Also, by the way, notice that the line of symmetry is x equals 3, which is halfway between 1 and 5. So, now we've got a new summary. Everything I had before still stays the same, but the line of symmetry, or the coordinates of the vertex, are the average of P and Q, halfway between P and Q. So that's another important little fact that sometimes makes it easier. And you can also write your quadratic in a factorized form like this. The 2 examples I showed you were pretty easy. You can try yourself with a more difficult example and see if it is true. It will be true, but explore that for yourself. Okay, there's lots more we can learn with quadratics and lots of problems we can solve, so we'll do that now, and watch out for more videos on quadratics.